Thank you. Thank you. Wow, spontaneous applause. That's the first time in my life, actually. Thank you very much. Thanks for having me this evening. I'm Jimmy Nilsson, running Factor 10 since the beginning, 18 years ago. And I've been doing software stuff for 35 years. And I aim for 10 more. I've said that for a while, so we'll see if that changes. So I'm going to start off this evening with a very short intro, setting the scene, trying to set the scene, and then the meaty stuff, the interesting stuff is going to be by Martin and Ranis. So that's the plan. So question for you at first. So what's the hinder of your organizational success regarding software delivery? Have you thought about that? What is stopping you? Some of you know the answer immediately. I actually added a pause here so you can think a little bit about it. While Martin, where are you? Can you help me with this? I think I said that anything goes, but I don't like this. Can I have something so I can look there? Perfect, thank you. Thank you. And the third answer was? PowerPoint. That was actually forbidden by whom? Do you remember? He said no more PowerPoint presentations in my organization. It takes too much time. Yes, exactly. He saw that as the big hinder. I'm not sure that was the biggest though, but it was one. Anyway, I think you have a couple of ideas what that could be. I just wanted to present this old favorite model of mine. It's pretending to show like a flow from left going to the right, and as you can see, there is a formation here causing the flow to go down a little bit. So when we have this situation, it doesn't really help to push more now. Of course not. We are just adding to the queue here. The queue is getting bigger. Nothing has happened here. The flow is exactly as it was from the beginning, even if we pushed a lot here. And it's the same if we try going from the other side, try to pull harder, drag out stuff. It's still not possible because this is causing the constraint here, of course. So this is the bottleneck model, which I come back to all the time during those 35 years. It still seems to be a problem here. It is the problem that we are seeing all the time. This is actually our hinder, I think, for our organization's success regarding software delivery. So when looking for this bottleneck in the big situation, I think we should start from the business perspective, the domain perspective, of course. But this is a Foo Café evening. We are allowed to geek out, so we skip all that crap. Who believes in that anyway, domain-driven design and things like that? Nobody, of course not. The only thing that matters is how fast we can type, as we all know. No, but we will go down and just assume in this situation now, actually we have concluded that it is our software delivery capability that is causing the bottleneck. That is the bottleneck for the situation, so we are going to look into that. And my colleagues will help us out with a couple of ideas for what we can do about that. In a couple of minutes. So 6 years ago there was a book published called Accelerate. Still to this date, when I open it up, I still find myself nodding. Yeah, it seems to be okay still, I think. It's based on academic research for a couple of years. I think it was like 5 years before the book. It has continued. But up until that point in time, at least, I think they made great results, and they were happy. They were helpful to publish those results in a popular formatted book rather than just an academic report, which might be a bit harder to eat. So this is about the DevOps adoption in very many different companies all over the world for a couple of years. And they looked into what is helping the most if you want to improve the software delivery capability. They find there are like 24 different areas that are the most important ones. And we're going to look into a few of those tonight. But just a few words before. One thing that is causing a lot of problems in many organizations I've been into, at least, is what to measure. There was a gentleman called Goldratt who has come up with the idea of theory of constraints, which is often connected to the bottleneck model. He said something like, tell me how you are going to measure me, and I can tell you how I will behave. And please don't complain when I'm doing stupid stuff, because it's your fault, because you told me you're going to measure me like this. So how to measure things, that's really, really, really important, actually. So you can have one of those two situations running like this on, well, creating hot air or something, I don't really know, or as I'm really hot now. Or we can create some results. So we should, of course, not measure activities. We all know that. We all see that all the time, I would say, in companies we face. It's happening so often. But we should try to shy away from that and rather measure outcomes. So by doing that, we will go from only being busy into actually, well, doing business. That's the idea. And I strongly believe in that. So when they presented those 24 different areas to focus on for improving the software delivery performance, they also present a couple of different metrics they came up with that are actually really powerful in predicting how the performance would be, and also very powerful for us to use those metrics for guiding us into becoming better. By tweaking those or getting better results from those metrics, we will also have a better performance, actually, with high certainty. Those 4 metrics are lead time. Try to have it as short as possible. Try to have as frequent deployments as possible. If there is a problem, see to it that the time to get out of that problem again is as short as possible. And finally, the change fail percentage shouldn't increase while doing this. But when some of you, I'm sure, have tried this out in your situations, and you have probably seen that actually by shortening the lead time and increasing the deployment frequency, if you do that in a good way, you will actually see that this is going down, which is totally counterintuitive to many people, not in our business, I would say. So I think those metrics are really a good thing to try to see if they fit in your organization, and I think you will benefit from doing that, actually. So why do we care about software delivery performance at all? Well, they are saying from the research the following. They talk about profitability, market share, and productivity, and they say analysis over several years show that high-performing organizations were consistently twice as likely to exceed these goals as low performers. And all of a sudden, we have almost proof that it's actually super valuable for our organization that we are improving in our performance regarding software delivery. This is powerful. In research, this is considered to be, they go for like a tiny fraction of a percentage. Now they have like 100 here. That's really different. And this is why I buy those books all the time. Martin has one with him. And the best question tonight, I think we'll have that book, right?
Let's see if you can come up with something interesting.
Yeah. I buy those books in tens at once, and I try to find the CEO of the company and put that on his desk or her desk all the time. That's my big plan. In 10 years, there will be change, I'm sure. But the fun thing is that actually, as you might have noticed, those people being in those C-level roles, sometimes I've had that idea in the past that maybe they are not so smart because they behave strangely. It's the opposite. They are super smart. It's just us haven't told them. When they find that book and see a couple of things, they say, it's actually like me reading it. Yes, 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 yes. They become so happy. They start crying out of happiness. All of a sudden they understand you guys. Oh, so this is why Henrik has been telling me to do it like this. Why didn't he tell me? It's important. This is crucial. They are extremely fond of this situation, actually. It's, well, please, please.
So I should have a microphone as well. I was trying to connect two things you said. One is, tell me how you will measure me, and that's how I will behave. And then the other is frequent deployment. So basically, if you tell someone, the more frequent you deploy, the higher score I will give you. So won't that give the effect that people will deploy without any real content? I mean, with as little content as possible, and we will not kind of gain anything.
That's
How
good.
do we get around that?
That's a good point. That might happen. I haven't seen that actually. Have anyone seen it? I actually thought you were going to say, Henrik, that well, I just deploy crap all the time, but no, that's not happening because they will tell you we will measure all four, and if you deploy crap, you will see that the change failure rate will go up. But you're right. You probably could get away with that. But maybe Goldrat wasn't perfectly right. We don't do stupid stuff, do we? So I'm not sure. That's a good question, actually. One had seen that. A comment, maybe? Yeah. So maybe we need to guard this a little bit more than this. Well, yeah. So, damn, I wish I could answer that question better, saying, no, no, Henrik, you are wrong. Oh, you're right again. Yeah, there is a risk for that. You're probably right. Cool. So what we just said is that software delivery performance is helping the organizational performance. We have all of us have known that for forever. It's just that at least I've been waving my hands and said, I believe, I think. Now it's more like proof from this academic research, and that's quite nice to point to that. Well, they said that. Please find a study that says they are wrong. Otherwise, it's right. I think that's how academia believes, at least, and well, works for me. Not everybody thinks too much about the organizational performance. Maybe, I guess we all do. It's nice to be at a company that is doing good. It's just, yeah, nice in every respect. But what we all also care about is, of course, how we and our fellows in the company are feeling, how we are, well, are we hitting the wall soon, or are we actually doing well and feeling job satisfaction and good mental health? This is actually, according to the research again, saying that in those performant companies, you could believe that maybe people are stressed out, they are working like crazy. It's the opposite. They are performant regarding software delivery, but they are not killing people. The opposite. People are having a better time. Maybe, I guess when you think about it, makes sense. It's nice to feel that, we did a great job today again, me and my team. That's really good, I think. So, yeah, makes sense, I guess. So, non-commercial performance is also gaining from how we succeed in developing software. Okay, so the overall idea then is how can we maybe we can organize for making this automatically become better than it used to be. And well, I think this simple model says one thing about it, of how we can avoid those situations when we are just waiting in queues. So this is a quite common way of organizing a flow for creating some outcome. So we have different departments that are highly specialized in doing something. So maybe it's some marketing department, some hardware department, some software department. I made this up now. Maybe that wasn't the best example. Anyway, I'm just thinking about those people being super proud on what they are the best in the world at doing. But maybe they are thinking more about that actually than the holistic view or the outcome. That's a big common risk, at least, I would say. So what happens is that they come up with something, it hits the border of this department or this group of people, and they say, this is crap, actually. Maybe they have a measurement saying that there's a ticket coming in, and the more tickets we answer per day, the better we are. So they say, crap, and send it back. That's a perfect way of resolving that ticket, of course. But that is not helping at all here, of course not. So this is, again, a very common situation. Also, I haven't found the thing to refer to, but I've heard it frequently said that as soon as something leaves a team, that all of a sudden it takes like 10 times as long. If the team can do it on its own, it takes 1. If you have to ask another team for help, it's times 10. Do you see that at all? Maybe it's times 8, someone says. Jimmy, you're wrong, it's not 10. 8, but you get the picture. It adds on to it. So that's one way. We are doing that a lot, but maybe we could try this one instead. So now we don't let those people of having special interests be only together. Now they have to mix up with different skills in a group. Some people hate that at first. So that takes some time. You can't just force people to do that. But most like it, and especially when they see the result of it. It's a great way of quicker getting to a result because you have all people you need in your team. I talked to a CFO once about this, and he said that, well, this is crap. We could never do it like that. Don't you see that you have a duplication? People doing similar stuff in 2 different boxes, and this is just not cutting it. It's also the case that some people here with different specializations are super expensive and few, so we have to keep them busy all the time. Let's put them there, and so they have full utilization all the time. That's much better. But I asked him, what do you do when you have a serious problem in this situation? Really, really life and death situation or close to it. Oh, that's easy, he said. I just take the right people from the different apartments, put them in the room, take the key and go away. I lock the room. And I wait until they are done, and they always finish it quickly. And I think, well, maybe that you're telling me actually that sometimes that could make sense. Maybe it's not one or the other, of course, as you all know, but to make the point. So it's no coincidence that I made this lower, because it's much quicker to result. That's the point here. And being quicker to result is good because then you get feedback. So even if you did something that wasn't good, you know that quickly and you can adjust. Longer time until feedback, that's a big problem, of course. Looking at what we've been doing, most of us, for a long time, developing software, it has often looked like this. Typical waterfall process, I guess. So you start with some requirement gathering, development, and then there is QA. Security is looking into the situation. Operations is asking how to install stuff, and then the users get it. That is quite a lot like what I showed to the left before. But we have changed that quite a lot. We are doing shift left, for example, moving QA and development together. And then we realized that the bottleneck has just moved. Now it's not QA, which is the bottleneck any longer. Now it's security. Oh, shift left. Oh, operations, shift left. And all of a sudden we have this DevOps team, or DevSecOps, or whatever we call it. So we've done that. It looks a little bit messy here. Maybe that's what happens also. But it's good messy, I think. So I think we have fast forwarded to where most of you are today. Maybe you are in something like this. You've been trying this out, what I've talked about here. And still, I see it often that highly performant organizations are still having more things to push. that could be improved. So that's what we are going to talk about actually. So even if we are doing all we have talked about here, there might still be few situations, a couple of situations in those quite gelled teams that you might have, which are working like a charm, but still they have a couple of things that could be improved. It's always the case. We can always get better. That's the charm, I think. So that said, when starting to talk about those things, in those very skilled teams, there is some friction actually. It's not, oh, good idea, let's do that. Well, they have been good and they have started to, well, maybe created a little ditch in the concrete floor because they have done it in a certain way for a long time and it works. Still, it might be good to go up from that ditch and see if we can improve still. So those situations, they are so common even in those skilled teams that they are taken for granted, almost like the law of nature, but they are not. And that was the introduction before I asked my two colleagues to actually tell you the interesting stuff here tonight. So Martin will start, and he will talk about waiting for people, or wait time in people queues. And then Ranis will continue, and actually I made this up. We'll see what Ranis will talk about. But I thought, well, Ranis would probably talk about waiting for machine queues. Maybe a little bit, I think. Maybe a lot. So over to you, Martin.
So, better software faster, right? Are we on track? Thank you for the introduction. That. So, Conti, Cogti, whatever. We're talking about stuff like continuous integration, continuous delivery, and continuous deployment. And CI/CD, what's the D? Is it delivery or deployment? Confusion, maybe. So let's see what are we actually talking about. So continuous integration could be seen as the build automation around integrating stuff into main, but no focus on long-lived branches, right? Continuous delivery is sort of the overall scheme that Jimmy was talking about, making sure that you can release on demand, which is what sort of accelerates is all about in the big picture. And continuous deployment is trying to always deploy to production every change you have. And we won't really talk about that here. But we will talk about continuous integration, and a better definition perhaps is that to get everyone's changes continuously integrated into some kind of main branch or master branch or a trunk or whatever you want to call it, and add some automated verification as well. And there's a debate, obviously, what does continuous mean? Is it once every minute, or is it, but the writers of the Accelerate book thinks daily is good enough. In the book and on the net, there's talk about trunk-based development, but some minds in the industry, such as Martin Fowler, he thinks that maybe that isn't such a useful distinction. So sure, it's very much the same. I think trunk-based, I would say that it's the same thing without necessarily doing all the automation on top of that. But workflow is the same. So I'd like to see if you can have a metaphor running here that is that commits are like fresh fish. So you want it integrated or cooked or whatever in your main branch instead of lying around in your branches. So if you're working here, if this is fresh fish and that's the processing machine, perhaps that's you're going to have a big backlog here that's perhaps is going to be smelly code here in a second. So one question is if we're doing CI, I mean, are we checking the boxes? And one simple way with 3 questions from one of the authors of the Accelerate book is if everyone is getting their changes in daily, if every change runs the unit tests, and a broken build is fixed within 10 minutes. And if you have that, you can have my CI badge. That's okay. And that's good. But if we zoom in a little bit more, we can see some warning signs that is common. We see people saying, oh, of course we do CI, CD. And then we look a little closer, and we have some of the common warning signs. I've tried to collect a couple of them. So the obvious first one is work isn't actually integrated quickly. So it takes perhaps longer than a day. And this is sort of, if you have a small team, you have something, you have stuff that you worked on 2 days ago isn't in main, that might not be a problem if you don't generally have merge conflicts, you have good communication in the team. If you're 3 people, or I mean, maybe a day is, or 2 days, or 3 days is good enough. It's more about not stepping on each other's toes than actually keeping a day as a measure, right? But think of it as fresh fish, and if it's in a box for too long, it looks stale. And this is sort of the metric from the Accelerate book here, is that the low performers, the red curve here, shows that the more devs you add, and you take longer you hold on to your fish longer, you scale negatively, so you have fewer deploys per dev. So if we're 15 people, you might have 4 deploys a day. Instead of, if you're a medium performer, the blue line, then you might be close to 15 deploys a day. But if you're in a high-performing organization, never stepping on each other's toes, then you can integrate more than once per developer per day and deploy. So I haven't put any numbers here, but it's in the book if you want to look at the actual numbers. But the main idea is actually not having good performance here. By integrating too seldom, you don't scale. Okay, that's the takeaway here. Okay, so second warning sign. Yeah, absolutely. Want me to go back a slide?
You told us a metaphor, Martin. Now we all are trying to have that killed, right? No, I like the metaphor, but even for a small team, after 3 days, does it really matter? The fish will rot anyway. It doesn't matter about size in that case, or?
I mean, it depends on what you mean by rot. If you mean fish, sure. If you mean my code is going to be over conflict with Nizar's fish in his branch. If we have communication, I'm working on the database thingy, you're working on the UI thingy, we are clear on that, then, I mean, it won't really rot. If you're a single developer, you're not stepping on your own toes, right? So this is, I think it's an okay metaphor for that. So it doesn't scale, because if you're 15 people in the team, you can't just, then you have a lot more coordination to do. And if you keep your branches short-lived, your fish fresh, then you have less toes to step on and less rotten fish, right?
Totally agree. So, but I was just trying to make it even stronger, that if it's not in main, you don't get feedback from your colleagues as frequently.
We will get to feedback in a few slides. Okay. So fine. I agree. That's you are losing out on other things. But from the continuous integration perspective, you might not cause any merge problems by doing that in a small team. Okay, so excessive people queues. I mean, if we rely on our work being reviewed, you have PR reviews, perhaps, code review, or test before it's allowed to merge to main, and people say, yeah, I only code review on Mondays, so that will have to wait. Sure, then that is obviously then creating issues, because one way to see this is that you can't have any pull requests when you're doing CI. because this will create a people queue. This will immediately cause additional delays. But I agree with the cat that it isn't actually about avoiding reviews or tests. It's about then focusing on the turnaround, getting the fish through the machine. And the cat likes fish, right? Fresh fish. So that works out, I think. But the daily clock, we need to start that clock when you write your code. You can't sit 2 weeks, then write a PR and then think that you're, as long as you merge it within a day, then you're fine. I mean, you have been holding on to the fish for a week, right? And you can't also stop the clock when you're done. You did a day of work and you stop the clock because you did a PR, and then your change will rot in the queue because someone needs to review it, and they only review Mondays. Okay. One might think that, okay, but I always keep up to date with the main, so I made more than daily, I merge changes from main. That works for you, but if I'm doing something that conflicts with what Ronis is doing, and we both merge into main, we won't notice until 4 weeks later when we try to merge that. So it doesn't work as a substitute, really. Okay, the third warning sign, I think, is the very frequent coupling of deploys with releases, right? So if we define words like deploy is actually delivering changes to some environment, and release is making that change visible, we need to understand that we don't need to do those two things at the same time. We could release it a week after, when, if you have the need to have someone look at it, try out some stuff, and you do that in the environment, and then you switch a flag or something, feature flag, some configuration setting, you have some role based, so only the QA group can access that feature until you think it's ready, and so on. I think that that could help you, because you then have a deploy that was a couple of days ago, but you release it when you think you're ready. And that is not the same thing as the push to production, so to speak. But you need to watch out if you have 10 feature flags and they sort of drastically change the behavior of the system, they add on stuff and change stuff. Then what do your CIP pipeline? Try out all combinations of all those things. So you need to think about that. This is not a silver bullet to fix all problems by hiding it behind feature flags. Okay, so in short, that release is a business decision. And when Jimmy thinks it's good enough, then we release it instead of releasing it when I merge my PR. Okay, the fourth sign we often see, even though you have a build pipeline, you have the main branch contaminated somehow. The build is red. Obviously, this causes a problem, because now I don't really know if if I try to do a PR and it's red, was it because of my changes or the other changes that I built upon? That's sort of it. Unhelpful for me. So in one way, this is sort of a symptom of a workflow that encourages us to merge to main and then other test runs. So we verify after we did the merge. Sometimes, obviously, often we try to verify before merge. But if you have 10 or even more PRs outstanding, and then you have merge one, you really should then you need to rerun all the pipelines, because now the situation in master is different, and often you don't have that because that wastes a lot of cycles. So often we have another test run after we merge, and then that detects stuff. So I think that's another issue really of typical environments, coupling deploy and release that we just talked about, because when I push to master, it's visible immediately to all of you, even though we haven't passed the verification step. So there's obviously a tension between the quick feedback from the build pipeline and you want comprehensive test suite. You have perhaps property-based testing, which you should have, and if you have that running, a million randomized tests, and it takes a couple of hours, if you do that on every build, you will slow everyone down. So perhaps you move that away, but then any change you detect there will obviously be detected after you merge domain. So there's a tension here that we have to make some kind of compromise. But as soon as we fix it quickly, 10 minutes was the rule of thumb, then that's perhaps we need to live with that. I haven't tried that, but I was thinking that maybe we could have some kind of, if you try to use Git repos and have an unstable branch we push to, and then they automatically merge into the main branch. But that still would only work for short-lived. If you have a 4-hour verification pass, I think that will still cause issues. Okay, so the fifth sign, this is also enormously common, that you don't actually have, your business especially, don't have the confidence that the stuff you have is releasable, even though everything is green, but my pipeline is green. We need to put QA on this for 2 weeks. Don't try to fool me. So, especially true for organizations that sort of, before trying out CI, they had long periods of stabilization and manual verification, because the experience has shown that it was not ready when the developers said they were ready, right? And if you try to keep stuff in within a day, just because you wanted it to measure, tick the box, you skipped some manual verification, I think that's obviously a recipe for disaster. So it's very common that people feel the need to do extensive QA to actually release this to customers. I think it's a sign of 2 things: insufficient automatic validation, and you haven't decoupled the deploys from the releases. I think perhaps you have some work in progress, but I haven't finished the invoicing stuff. Don't press that button; that will crash the system. So please don't do that. Yeah. So what should you do instead then, if you have something helpful things to think about? One of the things that is measured or mentioned, at least in the Accelerate book, is that the best teams always try to improve. They are not satisfied. They are not saying, yeah, the build is shaky, the tests are sometimes red, and you just rerun it. And you don't live with those kind of things. You try to improve it. You try to, if you always get bugs reports from some customer on this particular area of the code, you try to improve on that. So you don't have to do that again. So this is obviously easier said than done, but if we have a focus on building with quality instead of trying to inspect to find out that it wasn't good enough. One very common thing is that you have code reviews, but then you find out, okay, this is wrong thinking. Okay, this isn't, nice work on the PR, you follow the code standard and all, but this is a bad idea. So talk about the ideas. That's part of the improvement of your team. Whatever you want to call it, design reviews, or you have some kind of communication at least. And one way is to have pair programming or group programming. That's more and more common. And I think that's an excellent way of sort of communicating also design choices. But in general, strive to continuously improve yourself on design skills, code skills, test flow. Perhaps include a tester earlier, so if you have always a need of testing some changes, so have them included in the group programming session, perhaps. Everyone should feel responsible. It shouldn't be, yeah, I've done my PR, now it's QA, and let's hope they don't find anything because I'm going on vacation. Again, improving the verification automation, work to get feedback early and often, and we will talk a little bit about that soon. First, a little bit about verification automation. Yeah, as I said, if you have the same problem again and again, you don't live with that. Try to do something about it. But I hear you say immediately that end-to-end tests and so on that you would need to get higher confidence that this is actually working, it's error prone. Yeah, we know that because why you are probably, most people do end-to-end test in the end, right? And we know the test after. That's a we all know that for unit tests. So this is the same for end-to-end tests. If we had tried doing things more testable because we needed the testability, the test IDs on things on the user interface, or perhaps as a different way to log in test environments, so every test doesn't have to do 40 login steps and two-factor authentication and whatnot. Perhaps you could use tools like Storybook that can start up say a date picker in a specific state, instead of trying to find the order that has a date that is in the future, and you can so you could, instead of trying to find that state in your application, you set up a specific state in a isolated way and test that. And sometimes you have to do the investment to actually rewriting to make it more testable and automatable. And that's why sort of test first makes you do that work upfront instead. Work in smaller batches. There's sort of, I'm going to mention 3 ways, but what if my big refactoring that I'm working on takes a lot of time? I can't do it. I can't just push on non-working. I've ripped out the SQL code and I can't push now. Let me have a couple of more days, right? So that's where sort of you need to communicate a lot what you're doing, or you need to be able to split up your work in different ways. And one way is bottom-up design. I will talk more about that. Iterative development and branch by abstraction. So these are my 3 last slides about that. So bottom-up is you try to add up features bottom-up. So you sort of add the invoicing functionality in the back end, then you add an API on top of that. And I mean, you add the invoicing functionality with the test, and you could push that, right? No one can use it because it's not visible yet, but it's tested and perhaps even deployed. Then you add the API with tests and so on. Then you add the UI, and then when you have tested it good enough, because now it's deployed, right? It's not released, but it's deployed. Then you could release it when you think it's ready. So it's not necessarily visible until ready. But the problem with this kind of way of working, it works for splitting up the work in, but it doesn't work for what you said. You don't get any feedback because no one can actually use the invoicing functionality until it's sort of clickable, and right. So the other way of working is trying to work iteratively. You start out with something small-ish that kind of works. This is more of a shed than a house. Then you sort of make it more livable. Then people start using it already here and complaining it's so sterile. But perhaps if we have some nice curtains and perhaps a fireplace, that's kind of cozy and workable, and greenery and whatnot. Instead of the bottom up, you can't. I mean, you don't have any roof, so it will rain in. So no one can actually use these parts until here. Now you have this, but it wasn't quite what you wanted. So you need to, long after you started refining here, you need to try to steer in this direction, which is much harder. So this is a way to get feedback earlier. And this is another way of working that's specifically mentioned in a lot of presentations about trunk-based development, the branch by abstraction. So what this is, that we can consider this your whole system, and let's say that the red area is the database code, right? So there's a sort of a messy interface between the white application code and the red database code. And you want to switch to another database for some reason. And what you could do then is try to add an interface. It's not used yet, but you add an interface. You commit that. It goes into the code, into master and so on. Then you work this into the code, so you have an interface between the white layer and the red layer, and you perhaps did have to change both of them, the glue between them a little bit. And if these steps would take 5 days. You would have to do it smaller with just the invoicing stuff and then the order stuff and then the. So it could be done in parts as well. And then when you have the interface, you can write a conforming new implementation, but it's still not used anywhere. But you could flip some switches in the test environment and see that it works. And there's obviously unit tests and so on. And then eventually, when you think this is good enough, you can swap it in without changing any of the white real code, right? So this is a way of working that continuously pushes things to master. You don't have this living in a feature branch for 4 months before it's ready, but instead you have it in main, only not actually sort of switched to the real implementation until later. So I said that it was a battle, and I think this goes to show that I'm winning right now. I think that Micke said that we should take a small break now.
All right. So I'll see if I can follow Martin with some dignity. So Martin focused his slides on content and good messages, and I mostly just have stock photos. Let's see. Yes, there we go. Yeah. So I'm going to talk mostly about test automation, but I will also talk about pipelines. But I will start with test automation, and I want to talk more about this picture because I really like this setup here. This is an automated test machine at BT Trucks in I think it's in Gothenburg. So you can see here, this has lifted this 1 ton block of concrete 228,000 times. So they test the durability of. Apparently, they have lifetime warranty on the lift arms. So I mean, you can't do this manually. You can't hire someone, even if you outsource it. You can't hire someone to do these 228,000 times because they will get bored. They will quit and they will figure out something like this. No. No. Not even. So this is a perfect example of test automation. This is hardware. Lots of hardware, interesting stuff here. Like hydraulics, I bet this is really interesting. Testing other hardware that I think also actually includes some hydraulics. So what's test automation in our world then, in software development? Well, it's using software to test software. And I think like in the same way as with the hardware testing rig, we can't have humans do all the stuff because humans and machines, they differ in some key areas. So I have a short comparison of humans and machines. So humans are slow compared to machines, at least, because machines are really fast. How long time do you think it would take you to just lift this thing 228,000 times? I bet the machine can do it quicker. We are forgetful. I mean, I probably forget some of my slides I have today. Whereas machines are consistent, they never forget to run a test. If you give someone a checklist of tests and they're supposed to do it like every Friday for a week, for a year, they will forget to do some of the tests. They will sit there on a Friday and say, "Oh, I'm in a hurry, so I don't do these 3." Machines always does whatever you tell them. They do it perfectly, consistently, the same thing all the time. And we're also error prone. I mean, we make mistakes all the time. Machines, if you tell them to do one thing, they do exactly that, which means that we have to be precise in what we tell them. But once we get that right, it's repeatable. They do the same thing consistently, precisely. But as humans, we are creative, right? We make fancy lists and show it to other people, whereas machines, they are very programmable. We program them, and they just do what we tell them. We can invent new stuff, machines do what we tell them. So I think our creative side, that's what we should focus on, and we should use that elsewhere. So just to really drive this point home, I have a short video. This is Cypress. It's an end-to-end testing framework. So this is a machine testing a front-end application, a web application, and you see it enters tests. I mean, I could probably type that fast, but I can't do this fast. So it presses buttons, it enters tests, it clicks, it scrolls, and it checks. It runs 14 tests in 14 seconds, and that's unbeatable. You can't do this quick. So if I still haven't sold you on test automation, because automation is quicker, consistent, the whole point of doing all this, and Martin alluded to this in his talk, is so we can say this: all the tests passed, so let's deploy it to production. Once we have all our tests automated, we can be sure that once they all pass, well, it's fine, we're releasable. Let's deploy this to production. And if we do this well enough, we can even do this on a Friday afternoon. See you all on Monday. Deploy to production, I'm out. And no one will lose sleep during the entire weekend.
I will just object a little, because, like you say, what the machine does is exactly the same thing every time. But many errors come from kind of weird combinations.
I'll get to that.
Okay.
I'll get there. But to continue on the test automation, there are certain kinds of test automation. One popular thing is the test pyramid. I think this one comes from Google, where we build it up from. I'm supposed to say unit in here, by the way. Don't know where that went. And the rest of it also looks kind of weird. Interesting. So we have unit tests at the bottom. This is supposed to be the grunt of our automated tests. Unit tests are close to the code. They're very local. They're quick to run. They're fairly easy to write if you write your code correctly. And they should be like the most of your tests. It should be the base of your test automation strategy. And on top of that, then we have, here's supposed to be an integration test slice of the pyramid, which has somehow gotten lost. Yeah, I guess. I did, multiple times. These are.
I know that you've done this presentation in code. Would it have been possible to also test drive it?
Maybe. I do think that the framework that renders these are tested. Anyways, we have our integration tests. These are on a slightly higher level. They test how our code interacts with other parts of the system. They generally take longer to run, maybe longer to set up, are a bit more complicated to write, because you need to do the setup, you need to tie all these things together, and you need to prepare and then check. And then at the top, which is what you see here, is a huge top, is the end-to-end tests, which is where you run your whole application and you test drive it from the interface side. That can be, as with Cypress, we saw on the video, that test drives your web application. But it can also be if you have a REST API. You can run something like Postman that fires requests to your REST API. But then there are also other kinds of test automation that aren't covered by the testing pyramid. We're talking stuff like load testing. Maybe you need to handle 10,000 requests a second. So you set up automated tests that shoot 10,000 requests a second at your server to make sure that it can handle this load. We have performance testing, which is similar, but not really. It can be that we need to handle certain types of requests in a certain amount of time with certain speed. Maybe we need to run the end of day calculations and in 1 hour. Then we have, like Martin told you, he talked about property-based testing. I lumped that together with fuzz testing because they're fairly similar. It's basically you take a testing framework and you tell it how your code works. In fuzz testing, you don't really tell it how your code works. You just tell it what method to execute, and it generates input for you to see if you have missed any edge cases or if you have any weird results. Basically, it just shoots random data. In property-based testing, it's structured random data, I guess, at your application or functions to see if they break. This is, especially fuzz testing, is very much used in security testing because it can find buffer overflows and all this weird stuff that you really don't want happening. And then we have security testing. I mean, you can use fuzz testing and property-based testing here as well, but in security testing, we have things like dynamic application security testing, static analysis. We have dependency analysis, where you check if your dependencies have any known vulnerabilities. Things like that. And these are all automated testing. They may not be run automatically all the time. These you typically run on check-in or in a merge pipeline. These might be a manual step to start, but the tests themselves are automated. You don't have someone hitting refresh 10,000 times a second. So, common pitfalls when implementing test automations. And I think one of the major one is bad tests, because they give you a false sense of security. And if you can't notice it, by the way, his helmet is unbuttoned, so he won't be saved by that helmet. But if you have bad tests, you get a false sense of security. All the tests passed, but we don't really trust them, or all the tests passed, but we still find lots of bugs. And this, my Latin is horrible, so I'm not going to try to pronounce this, but it roughly translates to who watches the watchers, or who guards the guardsmen. And I think for me at least, I had an epiphany when I realized that when you do test-driven development, you write the test first, then you see it fail, and then you fix it so it works. So by seeing it fail, I know that this test can fail, and it fails for the correct reason. And then I can fix it and implement it and make sure it works. So even if you don't want to do test-driven development, I have no idea why you wouldn't, because it's awesome. At least see your tests fail. Make sure you break your code, see that the test you just wrote can fail, because otherwise you might be sitting there with a huge test suite, but still lots of bugs because your test suite doesn't really test your application correctly. And on the same note, you can be testing too much. Your test can be too tightly coupled to your code, whereas you don't test what the code does as much as how it does it. And that's testing the implementation instead of the behavior, whereas we're interested in the outcome of the code. What is it supposed to do, or what is it supposed to produce? Instead of testing that it does something 15 times. We are probably more interested in the result. This is very easy to do if you use a lot of mocks. So try to steer away from that. And one thing that also helps is to write pure functions that don't interact that much with, that don't have side effects. They're typically a lot easier to test in a black box kind of way. So test the behavior, not the implementation. Another thing that's fairly common is that tests are not independent. And that could be things like the order is significant. Tests need to run in a certain order or they won't work. And that typically is because there's some shared state somewhere. One test updates some configuration setting that's required by another test, and if you don't run that test, or if they run in the reverse order, the other test will fail. It could be because the setup is missing completely. We reuse the setup from another test that ran earlier to populate an in-memory database or something. Or it's faulty, we're missing some kind of step in the setup. And this can definitely cause errors when you run them automatically if they happen to change order. Maybe it runs, it works all the time, but then someone adds a new test and the order of the tests in the testing framework is changed, and now everything crashes. And it can also mess with our ability to run the tests in parallel, because if they run in separate threads, they might not set up their shared states correctly, or something runs before the other because, well, today these 4 tests ran a little bit faster. So this other test on another thread ran sooner, which gives us race conditions, and you definitely don't want race conditions in your tests. So this makes sure that you have atomic tests, I guess, that they can run in isolation. They're not dependent on other tests, and that you make sure that you clean up and set up before and after your tests. Another way that can be problematic is that the test suite takes too long. And I'm supposed to show the testing triangle here again, so we'll see if that works. But if your suite takes too long, you should probably revisit OLEG there. It doesn't work. It's supposed to be white as well. Is this running in Edge? Yeah, it is. So I'm blaming Edge. Anyways, you should look. If your suite takes too long, you might have too many end-to-end tests. You might have too many integration tests. Have a look and see what your distribution is. Maybe you should move some of the integration tests to the unit tests. Or maybe you have problems with non-dependent tests, that they don't run in isolation, or they require too much setup that is expensive. And there are techniques where you can make the setup once and then perhaps clone that and run the tests in isolation, but you reuse the setup, still having them isolated, but you just reuse the job. But I think the most common pitfall of automated testing, any guess? No. Well, then you don't really have automated testing. But yeah, that's a common pitfall. But say we're doing automated testing, what's the most common pitfall? No, I think you can test them out, but I think the most common pitfall is that you're still doing manual tests. Yeah, yeah. Yeah, that's the. Yeah, that's a whole different problem. But I'll talk a bit about that also. So I think if you're still doing manual tests, you still have that people queue that Martin is talking about. This is preventing you from achieving continuous delivery, because if you merge your code and then say, well, let's release this once Nizar has run all the checklists, then you're having a dependency on Nizar, and maybe he's busy release testing that other project, or he's ill, or he's on vacation, which means you can't release until after summer. So really avoid this. And I'm not saying that you should remove your manual tests. I'm saying you should automate the manual tests. Look at your manual testing sequence. If you have checklists, see if you can automate them. You probably can. There are very powerful testing frameworks out there. And if you can't, do you need them? Do you need them? Can you test them in another way that is automatable? Because if you do this, you free up your testers, because a lot of people have dedicated testers, then they can start doing exploratory testing. And I'll get back to that. So what does test automation done right look like? And here we come with test coverage. Test coverage is high, and test coverage is a problematic metric, but not if you use it correctly. So if you mandate that you should have test coverage of 80% or your pipelines will fail, and you have developers that are not on board with that, they will write stupid tests that doesn't test anything, but only exercise the code and give you code coverage. That's a problem with the developers, because you probably have the wrong developers, or they're not motivated enough. That's not a problem with your test automation. If you have developers that aren't interested in writing a good, stable product, that's another problem. So if we use test coverage is a metric that is really useful when it's low, because then you know where you should focus your attention on. Once it gets high, it starts to become pretty useless. There are many different kinds of test coverage you can look at. The most common one is line coverage, which is quite uninteresting. It just says that this line of code has been executed in a test. I think it's more interesting. I typically, when I use test coverage, I use branch coverage. So this is a made-up example of a Python service. And this lists the branches in the file. So this is your if statements, your for loops, your while loops. And it tests that every possible outcome of that branch has been